In this video, I'd like to take a look at sorting the elements of a list and then showing you another way to do sorting which will work not only with lists but also with the contents of a string or with tuples as well. So for the purpose of this example to start out, let's create this list called numbers, and as you can see, I've purposely created the list out of order so that we can demonstrate sorting capabilities. Now it turns out that built into the list type is a sort method that allows you to modify a list in place. So if I type numbers and a dot and tab, you can see all the different methods available to you for the list type in Python, one of which is sort. So let's go ahead and invoke sort, and that's an in-place sort. So now if I look at numbers after the operation, you can see that indeed it modified the list, and now the list is in ascending order by default. Now let me redefine that list once again, because you can also sort in descending order by default. So not by default, but by passing an argument to the sort method. So if we say reverse equals true, that says I would like to sort in descending order. So now if I take a look at the values in numbers, I can see them top to bottom, 10 down to 1. So that's in-place sorting with the sort method of a list. Now if you don't want to modify the list's contents, or if you're working with a sequence that's immutable, there's also a built-in function for Python called sorted. So let's go ahead once again and create that list with the elements out of order, and for this one we'll assign the values to a variable after the operation that's going to sort those elements. So let's say we have a variable called ascending numbers, and we're going to assign that sorted with numbers as an argument. Now sorted is the built-in function. It takes as its argument an iterable object, some sort of sequence that I can iterate over, and it gives back a list of values in ascending order by default. So if I now go and display the contents of ascending numbers, we can see that indeed this new variable contains the values in ascending order, but it did not modify numbers, and to prove that we can evaluate numbers and see that indeed it still contains the original values that we defined back in snippet 7. So that's sorted with a list, but I also mentioned the fact that you can use sorted with immutable types as well. So let's go and create a string called letters. We just have a bunch of random letters here, and they are clearly not in alphabetical order. So let's define that, and we can go ahead and use the sorted method, or function rather, with letters to get the characters, in this case, in alphabetical order. So let's call this ascending letters, and I'm going to assign the result to a variable for a moment just to prove to you that the original letters string is left unmodified. Now of course a string is immutable in the first place, so that should still be the case. So let's go ahead and sort the letters string, and now if I evaluate ascending letters, you can see that it gives me back a list, not a string, a list of the individual letters in alphabetical order. And actually it's not truly alphabetical order, it's in lexicographical order, where it's ordering those characters based on their underlying numeric values in the character set used underneath the hood, which is the Unicode character set. So here you see that we can in fact sort the contents of the string letters, but we get that back as a list containing the individual letters. And just to show you that letters remains unchanged, there is the original letters string. Now you can also use this with tuples. So let's say I have the following tuple, which is just the collection of strings, red, orange, yellow, green, blue, and let's create a new variable once again. So we'll call this one ascending colors, and let's sort that. So hopefully now when we evaluate ascending colors, we will see those in this case what appears to be alphabetic order, but again it's really lexicographical order. So if I had uppercase and lowercase letters in some of these strings, they may not appear in the same order that you're seeing right now. And separately, notice that it gives me back a list even though I started with a tuple. And finally, notice that if I display colors, it is still a tuple with the strings in their original order. So as you saw here, we were able to sort lists in place with the sort method, and we were able to sort lists, string contents, or tuples with the sorted built-in function. The one thing I didn't demonstrate here is the fact that you can also sort in descending order with the sorted method. So for example, if I say sorted, and let's say we want to sort these color strings in descending order, we can give a second argument that says reverse equals true, just like we did with the sort method built into a list, and we get back a list containing those strings now in descending order from highest to lowest. And again, because I'm using all lowercase letters, they're in alphabetical order and descending order in this case.